Hi guys, so I decided to go through and I'm going to do the next couple pages. So today or yesterday, we talked about the diamond problems and how that we could fill those in. And these are going to be handy, come in handy when we are working on our next unit. Okay, so those were the pages. This was just an extra one. So now this video, we're going to go over finding the GCF. Okay, so we have to remember what GCF means. GCF means the greatest common factor. All right, so for example, A is 16 and 24. Well, that means we're going to find all the factors of 16 and all the factors of 24 and see what works the best. So let's see, 16, we can do 1 times 16, 2 times 8. I don't think there's 3, and then 4 times 4, okay? Then 24 is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So now what we do is we take a look at the biggest number that these have in common. So I see 8 here and 8 here. There's no other bigger one. So like 12 is not in here, 16 is not with 24. So our GCF would be 8. Okay. Letter B is, let me just get my color. I'm only going to do a couple of these. So B is 15 and 30. So if I break those down, 1 times 15, 2, no, and then 3 times 5. For 30, 1 times 30, 2 times 15, 3 times 10, and we can keep going, but I already see that, 15 is my GCF. So my GCF of 15 and 30 is 15. So this you should have already learned before. Why we're going through this is because when we have monomials, binomials, any of that stuff, we need to find the GCF in case there is a GCF. So how can I find the GCF of a set of monomials? Remember, monomial means one term. Okay, so to find the GCF, step 1 is to find the prime factor, and we'll go over how you do that and look what they have in common. So finding the prime factorization, here's our first example, 16a to the third and 8a squared. When I prime factorize, this is just one way to do this. It means I'm breaking these numbers. Let's see, prime factorization, break all numbers down to prime numbers. Okay, and the first couple prime numbers are like 1, and a prime number is a number and itself are the only factors it has. So 1 is a prime number, 2 is a prime number because just 2 times 1, 3 is a prime number, 5 is a prime number, 7 is a prime number. Okay, so those are the most common ones that we're going to use, those up here. So 16, now how I do this, I'm just going to do 1 or 2 examples. So how I do this, 16, I'm going to break down. And what I normally do is I find, okay, what prime number can go into this? Well, 2 can, right? 16 divided by 2 is 8. Well, I can keep going. 8 divided by 2 is 4. 4 divided by 2 is 2. So I have all these prime numbers, these 2's on the outside. So that really tells me that 16 really is 2 times 2 times 2 times 2. Okay. And then when I break this down, remember we learned a squared is really a times a. Well, now it's a to the cube. So that means a times a times a 3 times. Okay, so that is how we prime factorize 16a to the third. Same thing with 8. We then see, well, 8, I can divide that by 2, it goes to 4. Divide by 2 more, that's also 2. So 8 can really be 2 times 2 times 2. And then again, a squared just means writing a twice. So when I find the GCF from prime factors, I look to see what they have in common. Well, they have 1, 2, 3 2's together. So 2 times 2 is 4 times 2 more is 8. So they have 1, 2, 3 2's and 1, 2 A's. So we would write this out. We'd multiply all the 2's together. So it'd be 8A squared is that GCF. Okay, we might see some of this, but it won't be as hard. So that's why I'm just kind of going to go through this part quickly, because then I'll show you what else we could do. You can practice some of these more if you would like. Once we get into these ones with different letters, that's where it gets a little bit tricky. So the first one, 5x cubed y squared z to the 6th. 5 was one of our prime numbers. Remember, 1, 2, 3, 5, 7. And then once we get up here, I think 11, but we won't go much higher than that. So 5 I can't break down anymore. X to the 3rd times x, x 3 times y to the 2nd. So y 2 times. And then z, I would write out 6 times. So do you see how this is getting way too long, way too complicated? Now 6 I could break down. 2 times 3, right? Those are both my prime numbers. Times w times x times, and then 4 y's. You guys see where I'm getting those numbers of how many times I need to write it out is in that exponent. 7 is a prime number, w, x times x, 5 y's this time. Okay, so what do they have in common? Let's circle it. Well, and none of the numbers are in common. They all don't have a w, but they all have one x. So x, x, and x. So they have an x in common times, oh look, they all have 1, 2, 1, 2, 1, 2 y's. 1, 2. The rest of it, we just kind of forget about because they don't have all that in common. So what is the GCF? The GCF of this is just y, or x, y squared. That's how we would write that. So there is an easier way to do this. And so I'm going to, if you wanted to practice breaking those down, you could. We won't really use prime factorization, but I'm just showing you what else it looks like. So finding a GCF part 2. This is the important one. I'll try to make this quickly so that our video doesn't get too long. But we're going to review the distributive property. So we're going to multiply this expression down here, right? So we distribute the outside to the inside. 2 and 3 is 6, and x to the 3rd times x would be x to the 4th. Plus 2 times 8 is what? 16, and just x to the 3rd. Okay, so think of factoring as undoing multiplication. If I can spell. So we did the distributive property and the box method and all of that, and we were putting those two terms together. So what we need to do now is we're going to take those out. Okay, so we are going to go backwards to do this. So how to factor out a GCF? Find the GCF of the terms. So what they have in common, we can ask ourselves, what do they have in common? Okay, since we blank to distribute, right, we multiply to distribute. To undistribute or factor, we need to divide by the GCF. Then we write the GCF outside of parentheses, like we're taking it out of those parentheses to show that it has been factored out or undistributed. So let's take a look at example A here. We've got example A. Oh, that doesn't work. The highlighter doesn't work. Example A, we have 3x squared plus 9x. So I look at those numbers. I'm going to look at the numbers and see what can I divide both 3 and 9 by. If you need a factor sheet or you need to list your factors, that's cool. You can do that. So 3 is 1 times 3, 9 is 1 times 9, and 3 times 3. So both have a 3 in here. So I can take the GCF would be me taking out 3. And then I look, this one has 2 x's, this one has 1 x. So altogether, I can take an x out of both of those. Okay, then it says to divide both terms by the GCF. So we found the GCF to be 3x. So then I'm going to take 3x squared plus 9x, divide each part by 3x. So what is left over? Right? And we know we have to put the GCF on the outside, and then what's left over to my insides? Okay, well, 3 and 3 goes away. I have 1 x on the bottom, but I had 2 on the top. So think of it as x times x on the bottom. I can cross one of those out. So I'm going to have 1 x left over. All right, the second part, 9 divided by 3 is positive 3, and my x's then cancel out. So my answer really is 3x times x plus 3. Now you could check that by distributing it back through and seeing if you get what we started with. All right, so another example. 4 and 10 are my numbers. So 4 is 1 times 4, 2 times 2. 10 is 1 times 10, 2 times 5. So what number do they have in common? The biggest number they have in common is that 2. So 2 comes out on the outside, but then I need to look at the variables. So this one has 3 x's and a y, and this one has 1 x. So they both have an x, so I'm going to take out an x. Then I'm going to divide this by 2x, divide this part by 2x. Well, 4 divided by 2 is 2. Left over, I took 1 x out, so I have 2 left over. I didn't do anything to my y. And then 10 divided by 2 is 5, and I took that 1 x out. Okay, so that's my leftover. My leftovers. Okay? Think of it like when you take leftovers home from a restaurant, you leave them inside the fridge. So we're taking out, whoops. I'm trying to write the answer. So I put my GCF of what I took out on the outside and left over what is left on the insides. Again, you can check by double distributing or just distributing and solving for that. Okay. So then they get a little bit bigger. So I'm going to skip this one because for time's sake, but let's take a look at some of these down here. Okay. So letter A, this is your more practice. I would like you to practice these for homework. So I'm going to do a couple of them. I'm going to look and see. I'll do E. Okay. And then the rest of yours are what I want you to practice for homework. So 4x to the third plus 8x squared plus 16. So now we have a few more, what do we call them? Terms, right? So we have a 4 and x to the third plus 8x squared and 16. So really we need to look, what are our factors of 4? Well, 1 times 4, 2 times 2, all right? What about my factors of 8? 1 times 8, 2 times 4, and my factors of 16, 1 times 16, 2 times 8, and 4 times 4, right? So the biggest number that they have in common, well, this one has 8 and this one has 8, but this one doesn't have 8. So all of them have to have, look, a 4. So 4 is going to go on the outside. Then I'm going to look and see. Whoops, I shouldn't have done that yet. So then I'm going to look and see, can I take a variable out of all 3 of these terms? The only way I can take out something from these is if it's in every single term, all right? So not every single term has an x. So I'm actually just going to take out a 4. So when I'm doing that, I'm really dividing all these numbers by 4. So that becomes x to the third, or 1x to the third, plus 2x squared plus 4, right? 16 divided by 4 is 4. So that's another one of your answers. We will continue to work on GCF. For some reason, students kind of struggle with taking out the GCF, but once we get to the more advanced stuff later this next week, we will need to always check for a GCF first. So when we go to learn factoring for other things, we always need to make sure we need to check for GCF first, okay? So homework A, B, C, D, and F for today. Okay, have a good day, guys.